Welcome back, everybody. This is asynchronous lesson number 2 for the week of September 7th. I'm going to be talking about turtle graphics today. Just to give you a brief synopsis, we've talked about the fact that there are different programming languages, Python being one of them, C++, Java, some things you may or may not have heard of. Back in the 1960s, there was a language popularized to teach little kids programming called Logo. And the cursor, the little icon that denoted where your location was on the screen, looked like a little green turtle. The screens of back in the day were green screen. They didn't have the full color that we had today. And so it just became colloquially known as a turtle. And so in modern languages, some of them, like Python for instance, has a throwback to that that we call turtle graphics. So right here we're in the shell. I'm going to go actually into the program area, not the shell area. So I'm going to go File, New, and then let me maximize that for us. So, you may or may not be watching this after or before we do our live lessons for the week. So let me just give you, again, just the briefest of overviews. The code that we write in here is the instructions we give to a computer. Some of the things the computer understands, some it does not. If it doesn't understand it, you get an error. So if I type in my name, the computer has no idea what that is. So what we do, if we want to put our name at the top of the paper, like you would in like social studies or English class, we put what's called a comment. So if you want to put text in your program code that only you, a person, can understand, excuse me, you put the pound sign. It is the shift 3 is the little, I think, the start of a hashtag. And anything that you write after that will be ignored by the computer. So I'm typically going to put my name, today's date. I'm doing this on the 4th, and this is period whatever, period 1 or 9. I'll put period 1. And this is a turtle graphics program. So just get used to putting your header at the top of the screen. It's your name, the date, period, and what the program does. One sec. Okay, so let's keep going. In Python and many languages, the language is so robust, so big, that they have what are called external libraries. It's almost like you have what's in your head, your knowledge, but if you need to know something else, you look it up. So Python has a set of built-in commands, but not everything's built in. So sometimes we have to import some files. So the first line of code I'm going to put here is the word from, and then turtle. That is our turtle graphics package. Again, it's from a language called Logo. And then we put import, asterisk. The asterisk is a symbol that you're going to see a lot in computers. It not only means multiplication, but it's also a character called a wildcard character, which, again, in layman's speak, the star means the wildcard character. It's like everything. So from the turtle package, import everything that's in there. That's saying the import star, import everything. As I hit enter, notice that I'm kind of spacing things out, almost like when you're making a paper. Some things you do single space, some you make double space. The vertical white space in Python is only for your benefit, to kind of make it easier for you and for me as a person to see. The horizontal spacing does matter, as you're going to see here in a little bit. But for now, just understand, you don't want everything crammed together. Like, look, what I have on the screen looks a lot better than if I just cram it all together and, I type some stuff here. It's too crowded. So you get used to, just learning what things get spaced out. At the beginning, you don't know, obviously, but you just get a feel for it as you watch, and hopefully you're doing this along with me as you're watching. From here, if you've ever done anything with like Lego Mindstorms or anything robotics, or if you watched our Scratch demo from the live lessons earlier this week, what you're doing is you're telling a cursor, you're telling the turtle to go forward or turn, things of that nature. So I'm going to say a command. This is a turtle command. I'm going to say forward, parenthesis, and I'm going to say 100. 100 is 100 pixels. Pixel is a word that stands for picture element. It's the little tiny dots of color that are on any computer screen, the more dots you have, the better. If you've ever heard of the resolution, like 1920 by 1080 or 4K, 8K, Ultra HD, that's really referring to the number of dots, the number of pixels on a screen. Again, the more dots you have, the smaller they are, so the crisper the picture looks. So on our screen, we're saying to the turtle, move forward 100 dots, 100 pixels. So if I just do this code, nothing else, I'm going to go up to run. Running a program means to tell the computer, do this, follow these instructions. So if I run the program, and you can either go to run or you can hit F5. I personally just use run because on a laptop, F5 sometimes like Control F5 or Alt F5 or something like that. So I just go run, module, and so it'll tell me I need to save this first. So I'm going to hit OK because you have to save it. And then my advice would be save it on your desktop, and then maybe you can like make a folder and move in your different folders that you're doing or your different files. So select your desktop, and then for the file name, I'm going to say turtle1, let's say. Hit save, and then it will draw forward 100. So the arrow is the turtle. It's facing to the right. So at the beginning of the program, I don't know if you saw it. If you're doing this on your own, which you should be, you can see it start, and then it's going to quickly go to the right. It went to the right 100 spaces. So I go back to my program code. Remember that programming is not just the lines you do, but the order you do them in. So I told it to go forward 100, and then I'm going to tell it to move left or right. And it's based off of degrees, 360 degrees around the turtle. So if I want to go at a 90-degree angle, I say left or right 90. So if I say left, parenthesis 90, with this command, the forward command, the stuff in the parentheses, the input, the domain of the function, is the unit of distance. It's a pixel, it's a dot. Here, the input that goes into the function is not a pixel, it's a degree. So you're saying turn left 90 degrees. If I do those two commands, if I run that, you'll notice the slightest of differences. See how it went forward 100, but now it turned 90 degrees and the arrow is facing up, ready to make your next move. So if I go forward again 100, I have just made this picture. It's going to go forward, turn left, go forward 90 degrees, and they're both 100, so those are congruent. For those of you that are in geometry, those are congruent sides, equal sides. If I were to make a square, I would just continue that pattern. I would say, and you can copy and paste if you want to, I would say copy, which you can do Control-C, or you can go up here to edit, copy. Copy and paste will be your friend in a lot of these programs we do. Forward, turn, forward, turn, forward, and then one last time, turn, forward. So you have 1, 2, 3, 4 drawings and 1, 2, 3 turns. With these instructions, you have made a square. Ta-da! Now, this is jumping ahead quite a bit, but with what you see here, you see there's a lot of repetition. If you ever find yourself making a program where you're doing the same line of code over and over again and copying and pasting, it's very likely that there's a shorter way to do it. There's a lot of commands that you won't learn here for a couple weeks, couple months. One of the more common commands is what's called a loop. It's something that takes your code and repeats it. So if you look really at what you have, you're going forward and turning, but you're doing that 1, 2, 3, and then we don't have the turn here, but we're doing that basically 4 times. So again, jumping ahead a little bit for those of you that want to think ahead, what I can do, I'm going to erase the final copied and pasted things. And instead, I'm going to put these 2 primary commands, the things that actually are repeated, I'm going to put that into a loop. So my loop, I'm going to go above that, and I'm going to say for FOR, which notice when I type 4, it turns orange. And then I pick a variable, which I introduced in the first asynchronous lesson, the shell. I'm going to pick a simple variable. From math class, let's pick like n, the number. In range, parenthesis, 4. Close your parenthesis and then put a colon, the 2 dots. Now, with this program I have right here, what I'm basically saying is I want to repeat this. How many times? I want to repeat it 4 times. However, if I go back to what I was saying earlier about the spacing, how do I know what things here get repeated? Just because these 2 lines are underneath it, how do I know those are the ones repeated? If I try and run this program as it stands right now, you notice it actually gives me an error. And if you look really closely at my screen, it says I expected, when I say I expect, I'm talking about the computer expected an indented block. Whenever you have a structure, and if you saw this in Scratch, the 2 lines, the forward and the left, should actually plug into this repetition, this loop. So I'm going to use my tab key. I'm going to tab those 2 lines into there. So now I can clearly see, because these are tabbed in, these 2 lines are what gets repeated 4 times. This loop, this repetition, does this however many times you say in these parentheses right here. If I want to go further, if I want to stop the loop, I would just keep typing afterwards, but I would unindent. If I want to put something inside the loop, I would continue on the next line, indent it. So the vertical space does not matter. It's the horizontal space that makes a difference, because you're saying, oh, these 2 lines, or however many lines, go inside this other line. So now with this code present, if I run the program now, you will see the same result. You'll see it went forward, left, repeat, 4 total times, and there you go. That is a square. Geometrically speaking, again, for those of you that have taken geometry, if I want to make a regular polygon, there are 360 degrees around it, and here you have a square. So there's 4 sides at 90 degrees. If I start making some changes, I could say, how about let's make 6, and how about 60? Let's see what that does. See, one of the cool things about this is you can experiment to see what happens. And ooh, look, now you have a hexagon. The product of those 2 numbers has to go to 360. So 4 and 90, 360. 6 and 60. What if I do 8? Well, you do 360 divided by 8. Let's say off the top of your head, you don't know 360 divided by 8. 45. But let's say you didn't know that. I could put 45 here, but I could also put a mathematical expression there. If I don't know it, I can have the computer calculate it. We're using a computer, so why not use the computer? So if I try it now, octagon. Super cool. So there you can see, some different geometric shapes. I mean, that's really what you're getting at here with this logo language, this turtle graphics. You can make different figures. You can draw. It's almost like if you know what an Etch-a-Sketch is. You turn the tiles and you can make the little cursor go up, down, left, right, different angles. Let's do something a little different with this. So you have your program here. If you want to save this program so you have a permanent copy, all you have to do, just go up, File, Save. And I'm going to then do a Save As. And then I'm going to make another file called Turtle2. That way I have my original, so I don't erase the code that I have there, but I'm also now going to have something new that I can mess with. So save Turtle2, and let's go back up here and let's modify our header. So name, date, period, turtle, graphics, program 2. So what am I going to do? Well, let's modify this a little bit. I'm going to say go forward, I don't know, let's say 50. And then let's turn 91 degrees, so a little bit more than an acute or a right angle. We're turning more than 90 degrees. We're turning back in on itself. Let me run what I have right now with 8, 50, and 91, just to show you what it looks like. It's like a little less than square tilted in on itself. Can't really see too much. Let's make it a little bit larger. And when I say larger, I mean let's do some more repetitions. Let's say I do 100 repetitions. Let's see what that looks like. Going a little slow, right? I mean, because you're doing this 100 times. Let me show you a way to increase the speed. I can close out the program. See, it says turtle terminator, raise the terminator. It's kind of funny. Basically, you just X'd out of the program. If I go back to my program code, if you want the turtle to draw at a different speed, what you can do is you can add a command before you start drawing, because if you wait till after, it's too late, because remember, this goes sequentially. If I go back up above my loop, I can say speed, parenthesis, and that just makes the turtle go a different speed. It goes from 0 to 10. If I do speed of 10, again, just want to kind of experiment and show you this. It goes really fast. And in fact, it looks like by drawing a bunch of rotated squares, you actually have made a circle. Let's make the circle larger so we can see it. So I have 50 right now. Let's say 500. Make this thing larger. Okay, now you see what happened. It's in the middle of the screen. 500 actually went off the screen. If I maximize this, it's still off the screen a little tiny bit. So you have to really, sort of be careful about where you do your drawings. I'm just going to stick with this because you can tell, like, ooh, that looks pretty. But it did. I mean, if you can look here really closely, it started at this line and it started drawing these tilted squares. Make this nice circle shape. Those of you that get to calculus will someday learn about tangent lines, if you have heard about them. You get enough of those, you're looking at a curve. Pretty cool. Pretty cool. What else can we do with our new little modification here? So I showed you in the previous example, you could make a mathematical expression here. Well, you still have this variable hanging out, this n. You're saying make n go in a range of 100. Now, obviously, like I said, this is a first week video. We're not doing this stuff formally. I just want to show you some fun things so you can understand what's going on. What's programming, what's this all about. I'm going to use n, which is here as like a counter. It's saying like go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to use that here in my forward command. I'm going to say go forward n. So it's going to go forward 1, then turn. Go forward 2, then turn. Watch this, what happens. So one of the fun things about programming is just taking what you got, changing a little bit, experimenting, making a mod out of it. Now you've made a nice little spiral. Just with one little change, the picture is completely different. And that's one of the cool things about programming is that you start with some little tiny thing and you just make like one little change and it greatly changes the outcome. That's one of the neat things that I really enjoy about this, and hopefully you can too. We'll wrap up by putting a little color into our lives here. The turtle graphics are just black and white at the moment, but you can add some color to this. And as I keep saying, this is just very preliminary, just fun introductory stuff, just to show you what this is. Don't feel like you need to fully understand or write any of this stuff down. It's just I want you to do it and just play and experiment. So again, up here we said speed. We did it before the drawing. Well, if you're going to draw something in a color, you need to pick up the pen of that color before you draw it. So I can't change the color after I do that code. I need to do it before. And the command is pen color. And notice that all these commands have parentheses. Speed is a function, pen color is a function, range is a function, forward is a function, left is a function. They have inputs. This is the number of things you want to repeat. This is how far forward. This is how many degrees. This is what speed. Well, the pen color, I mean, obviously, what color. I'm going to do this on purpose. This is, oops, hang on a second. This is going to generate an error. The problem with doing this virtually is it's hard for me to do one of the toughest part of the program, which is debugging your code, saying what happens when you make a mistake, because you're going to make a mistake. If I do everything perfectly in my videos, you're never going to know how to handle what happens when things go wrong. If I try and run this with pen color red, see, like this pops up, but there's an error here. It says red's not defined. You might remember from the asynchronous shell video, this is not a number. I need to put that in quotes. There are certain things that the computer doesn't recognize unless you put them in quotes. If I say red in quotes for the pen color, now it draws it in red. And see. Okay. So what colors are recognized? The primary colors, red, green, blue, white, black, things like that. There's lots of things you can, lots of colors you can use. Feel free to look them up. You can just maybe Google Python color choices or something like that. Let me show you one last thing, which is how to do multiple colors. I'm going to make a color list equal to using a square bracket. So again, getting way ahead of ourselves. But this is just introductory, so I just want to show you. This is fun. Variables can hold a single number. But in computers, not just math, you can use multiple characters for your variables. So like here we used n, which is no different than math class. N is a single letter. This, the word color list, is actually not a command. It's a variable I made up. It can be a whole word. It can be a phrase. There are rules about it, which we'll get into much later. But I'm going to make a variable called color list. And it's not just going to be a single color. It's going to be a list of colors. So using my square brace, I'm going to do quote red, green, blue, yellow. Separate them with commas, put quotes around them, and at the end, put in a right square brace. Now, how do we use that? Well, back in, I don't know if you guys heard the phone ring in the classroom there. So let me pick up where I left off. Again, I don't remember what I was saying, but we have the variable of the list of all of the colors we're going to use in our drawing. We're going to pick up a different pen in the midst of our drawing. So we move forward here to draw, and then we turn left. So it would make the most sense to put our color change right there before our forward. So I'm going to say pen color, parenthesis, choice, parenthesis, color list. Close one parenthesis, close two parentheses. Now, again, I want to show you something. When I do this, when I try it out, it's going to give me this error. Anytime you see something not defined, it's a couple things. You could have spelled it wrong. It could be a command the computer doesn't recognize. In this case, choice is a command that comes from a different library. It's from random numbers. Again, you don't need to know any of this right now. This is just a fun introductory program. So I'm going to go up top from random, import star. Random numbers are a huge part of computer science. Put that in there, and then this is where I'm going to leave you for today. I'm going to run my awesome little program here. Check out our little spiral. Different colors randomly, red, green, blue, yellow. Boom, there we are. Feel free to experiment. Feel free to Google Python turtle graphics. Lots of stuff out there, lots of things. I haven't even scratched the surface. Again, this is just a little introductory video. Enjoy, take care, see ya.